thank you very much for inviting us here. I'm Thomas Kluyver. This is Matthias Bussionnier. We're two of the core team developing IPython. I work in Berkeley with Fernando, Min, and Paul. Matthias is at the moment in Paris, just finishing his PhD. We're going to talk today about the IPython/Jupyter protocol and the separation between front ends and kernels. So it's kind of a talk in two halves. Matthias is going to talk about different front ends, then I'm going to talk about different kernels, and we'll aim to do about 10 minutes of talking each and then take questions afterwards. So without further ado, I'll hand over to Matthias.
Okay, thank you, Thomas. So I'm here to give you the bad news. We lied, we didn't came here to talk about IPython, so you already heard that with Steven on the keynote. We're slightly splitting IPython, and it's about Project Jupyter. You have the URL here if you want to go to the web page. There is not much yet on it. So where Jupyter come from? It's come from a reflection we have often on Twitter, like, why is it called IPython if it can do Julia, Haskell, Ruby? So this is a list of kernel we had. Last week we had someone who wrote a per kernel, and a few days after someone wrote Octave and Scilab 1. So we want to decouple IPython, the part of IPython that are language agnostic. We want to put it in a separate repo so that everyone from every language can come and don't have to worry about the IPython specific part. So we have network protocol for interactive computing, client for which speaks this protocol, the console, notebook, and Qt console. We have notebook file format and NB viewer. And why should you care why we're splitting the repo in two? It's because, like, if you implement one of these, one kernel or one front end, you get all the rest for free, which Steven also showed nicely. You basically just write a kernel, you have all the clients, and if you wrote one client, you get all the front end for free. So what is a client or a front end? It's something that connects to exactly one kernel. There are reasons for that we can discuss later. That's basically abstract the readable print loop. You send a message to the kernel, and the kernel will reply to you with a rich MIME bundle that can contain image, whatever, and decide how to display it. So there are, why do we want many clients? Because each client has its particularity. You can have multi-line editing or not. You can have a rich display capability, like in the notebook you can show JavaScript and HTML, and on the command line you cannot do that, but you can SSH and use it without doing an X forward or something like that. So there are a lot of reasons, and the thing is, we cannot have one client to rule them all. So there are many clients. We have a few with IPython. You know the Qt console. The Qt console is not well maintained, so basically it's maintained by the community, but it's still in core. You have the console, which is slightly different to the pure IPython prompt. It looks the same, but it's using the two-process architecture with a ZMQ channel that Thomas will speak more about later. And we have the notebook, which is slightly different because the notebook also has a file format and is able to store things on disk, so that when you load the notebook, even if you don't have the kernel running with the data, you can still at least see the graph and everything you did. Of course, we have also a lot of third-party kernel which are not maintained by the core team, which are not in the main IPython repo. So we have Vim IPython that was written by Paul Ivanov, which is not here today. We have Bpython. For those who know Bpython, it's a mix between the two that I will talk about later. We have Arraign, which is Emacs IPython notebook. Someone wrote a full Emacs plugin that talks to WebSockets and is not only able to connect to the kernel and execute Python, Julia, Haskell, and code, but it's also able to manipulate the notebook. So you have the full experience of the notebook inside Emacs. I'm not an Emacs user, so I won't show it because I don't know how to use Emacs. And of course, you have plugin for Sublime Text, Atom, and or your favorite text editor, and probably IDE, and it's pretty simple to write one if you want. So all these automatically benefit from all the architecture which is in the back end with the kernel after. And the last one we have is Collaboratory, which I will show just after. So Bpython is a wedding between like IPython and Bpython. It has been written in 2 days by Paul Ivanov, who just ripped part of Bpython and ripped part of BMyPython, mixed the two together, and did a terminal client, which is able to do some nice stuff. So I will do a demo. So Bpython is here. When you launch Bpython, of course, let's IPython console, and let's try to do it in another shell to see if it works. And yep. So here Bpython just launched and connected to a Python kernel. Right now it needs some refactor to be able to connect to Julia or other. There is some Python specific code in it. And unlike the classical, like in the classical hypertension, you can do things like ls, which works. In Bpython, it doesn't work because here it's a real IPython kernel. But you have it's written in top of Urwid, so you really have more interactivity than in the classical readline-based shell, which is if I import, you can see that it's already started to propose me some completion. So I can import numpy as np, so it works with still some bugs. And if you do numpy dot, you automatically, without pressing tab, get the list of all completion. And let's say I want to go to histogram. I already have all the information on how to use. So when you want to use terminal-based front end, Bpython is like getting the best of both worlds, and we're hoping to have some people who want to work on that, remove the Python-specific stuff, so that this could work directly on Haskell, Julia, and everything. So this is the front end which is not in the course. You can easily contribute. The code is pretty small. And to go to another end, we have Collaboratory, which is a new front end which has been written by people at Google. So the other name here, Kayur Patel, Kesar Tong, and Matthew Turk, and some others. It's a rewriting of the notebook interface. So it's not only connect to any kernel, but it also is able to read JSON file, and it stores JSON file on Google Drive, which means that you can have live collaboration between people that are writing notebooks at the same time. You can share on Google Drive and do whatever you are used to do on Google Drive, but with Python. So here I have a demo. You have the project, which is I have written, yeah, the repo is here, so you can go there and just, if you have IPython 2.2 installed, you can go to the repo and do Python -m Collaboratory and run that. It asks you permission to read your email, to do whatever, to talk to the NSA, whatever. And it opens this page, so you can directly ask to open a notebook on Google Drive. So the Wi-Fi is a bit slow. It doesn't work. Try again. Okay. So here I am on Google Drive. I can open EuroSciPy. And you might have heard about that you can run the Python kernel totally inside Pinnacle, which is a native client for Chrome. So you can have the full SciPy stack, which is in the browser. Here I'm running on a local kernel, so you have access to my machine. And you see here that you have the full notebook experience, where you can edit headers, you can edit Markdown, you have the math which work, and each output are isolated in iframe for security reason. So it's pretty safe. And they have some nice feature that if you do some magic commands, so I should have hidden that at the beginning, so you should at the beginning only, so that you can run matplotlib inline. You can import stuff and have plots. And you have these specific commands which are made only to work with Collaboratory for now, where you can just ask to show a form, and the form, basically you will drag that and it will change the value in the code, and you can just go there and rerun the code. It doesn't change much here, but if I change the period here, you should see that it's a sign. And for those who are in company and don't want their boss to see the code, you can just ask for the form. And you can easily explore data and rerun it. So right now, again, this works only with, there is some Python-specific path, but because it's just connected to a local kernel here, you could just set your profile to run a Julia kernel or a Haskell kernel or anything, brainfuck kernel if you want, and have this front end get automatically all the NB convert machinery and everything. And so to show you the difference between each kernels and how this works, I will leave the stage to Thomas. Oops.
Thank you, Matthias. So going into more detail about the kernel side of things, this is kind of a rough schematic of the communication pattern. So you can have several front ends connected to a single kernel, and they have two-way network communications. So things like when you type numpy.tab, that sends a completion request to the kernel saying, this is the text that I've already got here. The person has pressed tab with the cursor at this position. What's the list of options that I want to display to the user here? And the kernel will send back a message saying, these are the possible tab completions in this position. There's also a broadcast channel, so you can actually you can connect to a kernel and monitor all the code that's running in it and all the output it's producing without having the full two-way connection to it. That isn't used very much yet, but it's a possibility that is there for future interfaces. And the messages look something like this. So this is kind of a simplified form, but they're JSON messages. So if I type print hello world in the notebook or the Qt console, then it sends an execute request message with code print hello world, and there's various other fields that I've left out here, but those are the important ones. And the kernel sends a stream message back saying the text hello world with a new line has come up on stood out, and the front end will display that. And there are different messages for things like displaying rich images and things versus displaying text. Things like completion requests for tab completion has a corresponding completion reply, and there are introspection requests as well. So our own kernel is kind of designed like this. So when you type IPython at the terminal, what you get is this bit, so the kind of execution core of IPython plus the terminal interface. And the kernel is really just another wrapping of that execution core, but instead of exposing it to a terminal interface, it exposes a network interface that knows about these messages and can respond appropriately. So for other languages that want to have a kernel, there's now two paths to go down. So the classic approach is on the right, which is to re-implement all of the kernel machinery, the communications, the JSON messages and everything in your own language. So that's what the Julia kernel does, for example. What we've now made possible is that you can reuse our kernel machinery, our communications infrastructure, just subclass a kernel class and define methods for things like execution. So you don't have to worry about all of the semantics of the messages and things. You just need to have a way of driving your language from Python code. So things like I've written a little bash kernel, which I'll demonstrate in a bit, and that works via this mechanism. So it's much quicker with this to get a kernel up and running than it is to rewrite all of the machinery. But the downside is that if you want people from that language to come and help you maintain the kernel, then it's better to it's better to have that code written in that kernel's native language rather than having it in Python with a wrapper. So reiterating, this is kind of the set of kernels that we've got so far. And most of these have been written by people outside the core team, and there are more in the works. So we know that somebody is working on a PHP kernel at the moment. Quite whether you want that is another question, but that's the beauty of this system. People can work on these things without us having to approve them. So I am going to demonstrate a few different kernels. So Stephen kind of showed you the Julia kernel yesterday, which stole part of our thunder, but what he didn't show you is this new feature in IPython 3. I'll just make that a bit bigger. So the next release of IPython will have this drop-down menu, so kernels can register themselves with IPython, and instead of having to start separately, your IPython notebook, your iJulia notebook, your iHaskell notebook, or whatever, you can I just clicked Create New Notebook, and I can get this menu, and I can say, I want this to be a Julia notebook, and that starts the appropriate kernel and changes the syntax highlighting and things. And it's always, for some reason, there's a bug either in Julia or in IPython where this always fails the first time for me, but then it starts working. But we've got tab completion and everything working here. So, and the information about which kernel the notebook is using is embedded inside the notebook document as well. So if I reopen this R demo notebook, you see that the kernel indicator up in the top right has automatically switched to R. I didn't have to reset that manually. And I can start executing R code, and the R kernel this is something I started, and I'm gradually sort of getting the R OpenSci community interested in it. So rich output plotting and things works here, and somebody, one of the R community members was very interested in this and has integrated it with his R maps library. So this is a rich JavaScript map displayed from R, and he's got tools where you can add waypoints, and then routing is displayed within the map. I think the actual routing calculation is done in JavaScript rather than R, but the rich display mechanism for displaying HTML and iframes and everything is all working there. So the R kernel is another like full kernel implementation. So the 0MQ machinery and the JSON encoding and things are all implemented in R, in contrast to the Bash kernel, which is I'm told that there are 0MQ bindings for Bash, but but I didn't want to be the one trying to use them. So this is written in Python, and it just uses pexpect to create a virtual terminal and tell Bash that it's running inside that. So you can do all of the normal things that you can do in Bash. Man pages kind of work. There's this weird thing with formatting, and just for one final demo before we go to questions, somebody was testing out the infrastructure and wrote the chatbot kernel. So this, rather than when you execute a message, it like processes the text as a conversation with a chatbot. So you can hopefully, drum roll please. There we go. Okay, the AI isn't perhaps brilliant, but but we hope that there'll be a lot more of these interesting examples that we can demo at future conferences. Thank you very much. Matthias will come back now and we'll take questions on both parts.
So, of course, we said IPython many times, but we wanted to say Jupyter, of course. We're just not used to it. And one of the other features that will come in IPython 3 something is the ability to have one server. I mean, it's a separate project, but you can have install something which allow you to have one server and have many people connect to this server. Just log in, and each of them will have their account and have their notebook. So it's kind of a first approach to multi-user, which would come with that.
Thanks for the talk. Are there any ideas or plans around having multiple kernels that can interact with each other?
Not within kind of our sphere of activity. If you look up Calico, then this is this very interesting project to have. It's one kernel, but it can handle a load of different languages, and it has this special syntax for switching between them. And it uses it's something like an implementation of Java on the .NET virtual machine, and it's quite crazy. But yeah, for our own kind of work, we're thinking of kernels as really separate things, and I mean you can communicate with them like you can communicate between any processors, but there's no specific interaction features.
And yeah, of course, when you want one kernel that handles many languages, there is always this question of data sharing between kernels and also the cognitive load for users. We believe that having many languages is pretty tough. And so we have the IPython magic, of course, because we are scientists, we do crazy stuff. And yeah, nothing in the current architecture prevents you from doing one kernel that does many languages. We just don't want to bake in the core. We try to say as small as possible and make the abstraction necessary for people to write what they want. Because we have, like everybody here, we have really low bandwidth and not many people working on the project.
So what's the status with having some multiple user with resource management and isolation and everything? The idea, of course, being going towards exposing this as a service in maybe not a hostile environment, but an environment with people who don't really know what they're doing. And the question is not naive because Sage has been doing these things.
So you can define the way to start a kernel any way you like. So you can define a Docker kernel that each kernel will have a totally separate environment. But as I keep repeating on the mailing list and everything, the danger is not on the server side. Isolating clients on the kernel is easy with Docker and with virtualization stuff. The danger is on the front end, especially with the notebook, because you're in a web environment, and as soon as you have login and multi-user, you can still credential with JavaScript. So their danger, and everyone missing the point, is that when you publish some JavaScript in the notebook, we do some real hard work to sign notebooks cryptographically to be sure that you were the one who wrote the notebook, because at some point in IPython 1 and between 1 and 2, I could have written a notebook, send it to you, and by just looking at the notebook and opening it, the JavaScript could have access to your hard drive and run rm-rf / node preserve root, or even get your SSH key and everything. So the danger is in the front end, right? And it is a tough problem, which is much more difficult than just isolating the kernel.
I think that's orthogonal. But that seems like that vulnerability is orthogonal to what he asked about, because the vulnerability you're talking about is opening hostile notebooks. Right, and that's true whether I'm running the kernel on a server or whether I'm running.
No, it's cross-site scripting. If you look at SciPy video, you have a demo of Kai Kelly, which is at Rackspace, who basically do a phishing of Polyvanov and take control of his computer. You have all the problem you have on the web, even on localhost. Even if you're running on a localhost, if you're not on HTTPS on 2.1, you're vulnerable to remote code execution.
Yeah, to actually indeed piggyback on Stephen's comment. My question was not in a really hostile open environment, but more, I'm running a lab in an institution.
There is no safe environment, even in a lab.
Okay, we could hire you at the Atomic Energy Commission, but I'm less worried about passwords than about people making mistakes and bringing down computing infrastructure with segfaults or fork bombs or things like this.
Okay, so then you need to start the kernel in a way you want, because it's just if you can run a program that does what you want and that can expose port, then you can do what it works. You can, for example, have, instead of having just Python 2, Python 3, you can have different VNs, or you can have contained environment, or you can have whatever. You just need to write the spec for the kernel.
A quick question about plotting. So a colleague was using Spider and plotting in line, and then he wanted to take a diagram out of the Spider IDE and draw it as an interactive graphic, and I showed him he could switch to a Qt front end or the inline front end. I was surprised that with two consoles, one couldn't use Qt and another couldn't do inline plotting. You had to do one or the other. So it feels like the plotting is controlled by the kernel and not by the client. Is that true? Do I have a broken mental model?
Yes. So when you produce one of those interactive matplotlib plots in its own window, that window is actually coming from the kernel process, not from the front-end process. So I know people are working on better interactivity with plots for working in line. So matplotlib now has an NBAG backend, which is specifically aimed at drawing plots in the notebook. But yeah, the classic sort of Qt windows are displayed by the kernel, so the front end doesn't know anything about those windows.
But with the widget infrastructure, you've seen, for those who were there, Cyril's, where is Cyril? He's there. Cyril, the tutorials on widgets. So basically, widgets are an abstract way to do bidirectional communication between, for now, JavaScript and kernel. You saw also with Stephen's keynote. So you could imagine that this way of bidirectional communication could be used to have dynamic plots using Qt on the client side, whatever client side it is. But it's true that you have historical background, and Qt backend has not been thought at the beginning to be remote, and for now it's like that, and we hope it will change in the future.
There's one last question.
Just as a shameless plug, I'm hoping to do a lightning talk on the interactive matplotlib backend, so the MBAG backend. So fingers crossed, I'll get there to that. A question now, though. Is it going to be easy using this new interface, the kernel dropdown, to access various environments, so either through virtualenv or through your Conda environments or some other form? Is that the plan?
We've had a lot of discussion about what to do about environments, because there's virtualenvs, there's conda-envs, there's things like Docker containers. Other languages probably have their own environment tools. The answer for the time being is that we're for the moment not going to think about environments, and what you will be able to do is create a separate kernel from IPython's point of view for each environment that you have, and you can do that manually, or it will be scriptable to create a kernel whenever you create an environment. But yeah, whether it may be that at some point in the future we expose some notion of environments in a similar UI, but at the moment it's not clear how to do that in a general way, and the UI is already contentious of where we put every new button. So I mean, the hardest part of building all the infrastructure to make this new feature was the argument over where to put that button. And it's not really resolved. They just kind of said, okay, we'll let it be there for the time being.
So just to show you how to write a new kernel, if you're able to have a program that can take just one JSON file as a parameter, and use the JSON file to connect to the right port, then you get a new kernel. So for virtual env, you just have to say, okay, this is the syntax highlighting, so you just have to give a name like myvenv1. And here you make a bash script that take arguments that will go into the venv, start your kernel however it wants with whatever it wants. Just take one parameter and forward it to the IPython kernel which is installed in the venv, and you get your kernel in your venv.
Yeah, with virtual envs it's particularly easy because you can just, if you like have the full path to Python inside that virtual env, then it will launch with that environment set up. Great.
Okay, thank you very much, and thank you for keeping a lot of time for questions.